Question 1, part A, simplify m to the power of 2 in brackets to the power of 3. So the laws of indices, when we have a power of a power, so we've got a power inside and outside our brackets, tells us that we multiply the powers. So it's going to become m to the power of 2 times 3, which is m to the power of 6. Make sure you're writing your powers smaller and to the top right there, so it's really clear how you're writing that expression. Part B, simplify x to the power of 5 multiplied by x to the power of 8. The law of indices for multiplication says that if we have the same base number and we are multiplying, in this case we've got a base letter, x, we simply need to add the powers. So it becomes x to the power of 5 plus 8, so that's going to be x to the power of 13. Part C, expand the bracket. So 4p multiplied by p squared gives me 4p to the power of 3. And then 4p multiplied by positive 3p gives me positive 12p squared. I'm just going to check that I've multiplied everything on the inside of the bracket by everything on the outside of the bracket, and then I'm going to write what I think is my answer on the answer line. Question 2. Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes 68% of the people will drink coffee. Part A, using this assumption, work out the amount of coffee Johnny needs. Give your answer correct to the nearest gram. Okay, so each person who drinks coffee will drink 2 cups of coffee. And there are 10.6 grams of coffee per cup. So 2 times 10.6 grams tells us that for every person that drinks coffee, Johnny needs 21.2 grams of coffee. He assumes 68% of these people will drink coffee, so we want 68% of 800 people. So I'm going to use the multiplier 0.68, because that's 68% as a decimal. So Johnny is assuming that 544 people are going to be drinking coffee, and at 2 cups of coffee each, they're going to need 21.2 grams per person. So 544 times 21.2 grams is 11,532.6 grams of coffee in total. We want our answer to the nearest gram, so that 0.6 is going to round this up to 11,533 grams. Part B. Johnny's assumption is wrong. 72% of the people will drink coffee. How does this affect your answer to part A? Well, 72% is more than the original assumption of 68%, so Johnny's going to need more coffee. So how does it affect your answer to part A? The answer would be bigger. Johnny will need more coffee. Because more people are drinking it. Question 3. ACF and ADG are straight lines. BCD and EFG are parallel lines, and they're also marked with that little arrow there to denote parallel lines. Show that triangle ACD is isosceles. So this is triangle ACD. So that's the one that we're working towards showing is isosceles. Give a reason for each stage of your working. So isosceles triangles have 2 sides equal and 2 equal base angles. So I'm going to work out as much information in terms of angles as I can to identify whether or not ACD is isosceles. I can't do anything with the sides because I haven't got any of the sides labelled, but I can work with angles. So I'm going to start by finding this angle here. So this is angle CFG. So angle CFG equals 180 subtract 125 because they're on a straight line. So 180 subtract 125 tells me that that angle is 55 degrees, and I'm going to give my reason there for that stage of working, and that is angles on a straight line sum to 180. Okay, so now that we've got these parallel lines here, what I can work with are angles in parallel lines. So if I take that line, that intersecting line of these two parallel lines, it gives me this F shape, which tells me that this angle and this angle are equal. Okay, so angle ACD equals angle CFG. And the reason for this is because corresponding angles are equal. So I'm going to write corresponding angles are equal. So I know that that's 55. Now here we have another straight line. So I can get angle ADC. So angle ADC is 180 subtract 110. Which is 70 degrees. So that tells me that that angle is 70 degrees. The reason for that is angles on a straight line sum to 180. And I've already written it there, so I'm not going to write it again. And then now we're going to find this angle here. Because for this triangle ACD to be isosceles, we need two equal angles. So if this angle equals one of these two values, it's an isosceles triangle. So the next reason is angles in a triangle sum to 180 degrees. Oh. So I'm going to do 180 subtract the 55 and the 70 that I have labelled inside that triangle, which gives me 55 degrees. So we have two equal angles here. So I've shown that it's isosceles, but I'm going to say here, therefore, triangle ACD is isosceles. It has two equal angles. Question 4. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size? So 14 hours for 5 identical pumps. If we've got less pumps, we're going to expect it to take more time. So be aware of that when you're checking the suitability of your answer at the end. If there are less pumps filling the water tank, then it's going to take longer to fill. And then we just need to figure out some kind of proportional relationship. So I'm going to do 5 divided by 4, okay? Because that will tell me how much work each of those 4 pumps has got to do. So it's got to do 1.25 amounts of work as each of these 5 would have had to do. So if it's 1.25 the amount of time, I'm going to do 14 times 1.25. And that tells me that it would take 17.5 hours for 4 pumps to do exactly the same as what 5s would have. Question 5. A and B are numbers such that A is 2 squared multiplied by 3 to the power of 4 multiplied by 7, and B is 3 squared multiplied by 7 squared. So these numbers A and B have been written as products of their prime factors. Part A, find the highest common factor of A and B. So the highest common factor when dealing with prime factors, if you were to sort them into a Venn diagram, would be anything that occurs in the middle. So anything that occurs in both. So what I'm just going to do is I'm going to expand these so that they're not written in index form. So 2 squared, 3 to the power of 4 and 7. Then I'm going to do the same for B. So it's 3 squared and then 7 squared. So now I'm going to look at what they have in common. So we have 3, 3 and 7. So my highest common factor is 3 times 7, which is 63. Part B, find the lowest common multiple of A and B. So the lowest common multiple of A and B would be the highest common factor multiplied by anything that's left, that hasn't been included, that wasn't common to both products of prime factors. So we're going to do 63 multiplied by 2 squared multiplied by 3 squared multiplied by 7. This would be all of the information that's included in your Venn diagram if you were to draw one. So 2 squared, 3 squared, 7. So the lowest common multiple of A and B is 15,876. Question 6. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer to correct it to the nearest day. Okay, so what we've got to realise here is it wants how many days, but our flow rate is given in seconds. That's meters cubed per second. So we need to work out what that would be in days when we get to our final answer. So the first thing I'm going to do is I'm going to find out how many seconds it's going to take. So I'm going to do the volume of lava divided by 11.9. So be careful to enter this in your calculator accurately. So that's going to take 5,647,529.412 seconds. Now we need to convert it to days. So to go to minutes, we divide by 60. Hours, we divide by 60 again. And then days, there are 24 hours in a day, so we would divide by 24. So this answer divided by 60, divided by 60 again, and then divided by 24 tells us that it's 65.36492,375 days. Once our answer correct to the nearest day, so this to the nearest day would be 65 days, because that 0.3 is less than 5. So we're going to keep it at 65. We're not going to round it up. Question 7. Here is the graph of y equals x squared subtract 2x subtract 2. So this is our quadratic graph here. Positive quadratic graph. Part A, write down the coordinates of the turning point on the graph of y equals x squared subtract 2x subtract 2. So the turning point is that point where you could draw a line of symmetry. So the point on which this quadratic curve is then going to mirror itself on the other side. So we're going to read off our coordinate. So our x coordinate goes first, which is 1, and our y coordinate goes next, which is -3. Then it says for part B, write down an estimate for one of the roots of x squared subtract 2x subtract 2 equals 0. So the roots are where it crosses the x axis. So this point here and this point here. And it says estimate because actually we can't get exact values here. We can just estimate roughly. So this is 2 to 3 with 5 little squares. So each square must be worth 0.2. 2.2, 2.4, 2.6, and it's somewhere between 2.6 and 2.8. So let's go with x equals 2.7 for that positive solution. And then working this way, negative 0.2, negative 0.4, negative 0.6. Again, we're somewhere between 0.6. Oh no, it's on 0.8, I reckon there. So we're going to say x is also negative 0.8. And they're the answers that would go on our answer line. I'm going to write them again nice and clearly, remembering to include that negative sign. Question 8. A solid cuboid is made of metal. The metal has a density of 9 grams per centimetre cubed. The volume of the cuboid is 72 centimetres cubed. Work out the mass of the cuboid. Okay, so density is mass divided by volume. You might have also seen this formula triangle, like the speed, distance, time triangle. So if we're working out the mass, we're going to do the density multiplied by the volume. So the density is 9, the volume is 72. So 9 times 72 is 648. It's got our units there in grams, but if it didn't have it for us, because the density says grams per centimetre cubed, the volume's in centimetre cubed, so the mass must be in grams. And 648 is going to go on our answer line. Question 9. Some people were asked if they wanted a new television. 70% of the people said yes. 80% of the people who said yes wanted a television with a large screen. What percentage of the people asked said they wanted a television with the large screen? Okay, so 70% of people said yes. So we're dealing with this 70% of people, and 70% is 0.7 as a multiplier decimal. I'm going to work with decimals here, okay? So 70% said yes, and this is the amount of people we're dealing with, but 80% of these people wanted a large screen. So I'm going to work out what 0.7 times 0.8 is. And that tells me 0.56. So 0.56 of the people asked said they wanted a television with a large screen. This is a decimal. We want a percentage. So 0.56 times by 100 would tell us it as a percentage, which is 56%. Question 10. ABD is a triangle. C is a point on BD. So ABD is this large triangle. C is a point on the base of that larger triangle, DB. Work out the length of DC. So it's wanting us to find this length here. Give your answer correct to 1 decimal place. Okay, so what we can see here is 2 separate right angle triangles. We've got this right angle triangle ABC with an angle of 41 degrees labelled and a hypotenuse of 6.8 centimetres. And then we've also got ACD, which has an angle of 55 degrees labelled and the length, the base X that we're trying to find. So using right angle triangles with angles involved is going to be trigonometry. And for us to be able to find X, I need one of these 2 other sides. So I need one of the other 2 sides and the angle they've given us to find X. Now, I've got nothing that's going to help me find the length AD. So I'm going to find AC and I'm going to label it Y. And I'm going to find AC because it links to this triangle here. And I have an angle, I have the hypotenuse and the side I'm looking for. So I can start by using trigonometry here. So Y is the opposite and then this is the hypotenuse. So we're using the sine ratio. So sine 41 is equal to the opposite, which is Y, over the hypotenuse, which is 6.8. So Y equals 6.8 times sine 41. You can type it in your calculator if you want, but I would always recommend care when you are now going to use this value to find this. So I'm probably going to use this version of it instead of the decimals, just in case I write one wrong. So now I know what y is. I'm going to use this triangle here to find x. So y is still the opposite, but this time x isn't the hypotenuse, it's the adjacent. So I'm going to use the tan ratio. Remember SOHCAHTOA. O and A is the tan ratio. So the opposite is y and the adjacent is the side that we're looking for, DC. We've got the angle 55. So tan 55 equals the opposite, which is y, over the adjacent, which is x. Okay, so x is y, which is this here, 6.8 times sin 41 divided by tan 55. And I've kept it like this because that's easier to enter in my calculator without errors than this is. But also I've kept it in my calculator, so I didn't actually clear it, so I'm just going to press divide and then tan 55 there. So this tells me that x, which is DC, is 3.123766848. We want one decimal place. That 2 isn't going to change the 1. So DC is 3.1 centimetres. Question 11. The table shows some information about the heights of a group of adults. So we've got the least height, the greatest height, the median, the lower quartile and the upper quartile. Part A, on the grid, draw a box plot for the information in the table. So they've given us a scale here, and I'm going to use a pencil in case I make a mistake so I can rub it out. So if we look at this scale from 155 to 160, that's 5. And within there are 10 small squares. So each square is 5 divided by 10 is 0.5. So that's really important for when I'm plotting these, okay? So your least height and your greatest height are either side of your box plot. They're at the end of your whiskers. So we want to go to 169. So 165, 6, 7, 8, 9. So if I get my ruler. So we've got our least height there. And then our greatest height is 186. That's 185, 186. And what you'll notice here, I've made sure that those whiskers, the least height and the greatest height, are the same length, just to make it easy to read. Okay, the median is 177. So the median is a bar that represents the middle point of the data. So 175, 176, 177. So I've marked on my median. The next thing is the tricky thing, okay? So it gives us the lower quartile and the upper quartile, okay? So the lower quartile is at 174, which is here. And the upper quartile is on the other side of the median. So the lower quartile is in this area of the box plot. The upper quartile is on the other side of the median. So make sure you're aware of that. And that's at 180. And then it's a case of drawing the box and the whiskers. So we enclose the median inside a box with boundaries of the lower quartile and the upper quartile. And then we join the whiskers to that box for the for the least height and the greatest height. The box plot below shows the distribution of heights of a group of teenagers. So this is the teenagers and this is adults, okay? Part B, compare the distribution of the heights of the adults with the distribution of the heights of the teenagers. So we're going to compare these diagrams. So what we can say straight away is, because they're on the same scale, that on average, adults are taller. We'd expect that. But we're going to look at that median and that box here. Because if you look, this box is longer than this box. And that's the distribution, okay? That quartile, the interquartile range we call that. So you can mention that obviously the lowest height for teenagers is shorter than that for adults. And the the greatest height for adults is taller than that for teenagers. But we're going to talk about these things. So the average height is the median. So the average height for teenagers is 169 centimetres compared to adults at 177. But we're interested in this range, this distribution. So from 165 to 171. It's given us a range of 6. And then from 180 to 174 is also given us a range of 6. So actually, even though, as expected, the greatest height for adults is taller than that for teenagers, their distribution is the same. Their range of values, so the range of heights for adults and teenagers is the same. So they're both as consistent as the other. Question 12. Show that the triple bracket can be written in the form ax cubed, add bx squared, add cx, add d, where a, b, c and d are integers. Integers simply means whole numbers. So I'm going to expand those triple brackets. I'm going to start by expanding the first two brackets. So x times x is x squared, x times positive 3, positive 3x, negative 1 times x is negative x, and negative 1 times 3 is negative 3. So I've expanded two of the brackets, that third bracket is still there. I'm now going to collect like terms to make me have less terms to multiply by that third bracket. So we have x squared, positive 3x subtract x is positive 2x, and we've still got the subtract 3. Now everything in this bracket is going to get multiplied by everything in this one. I'm going to start by multiplying all of these three terms by x. So x squared multiplied by x is x cubed. 2x multiplied by x is 2x squared. Negative 3 multiplied by x is negative 3x. Now I'm going to multiply them all three terms by negative 5. So x squared times negative 5 is negative 5x squared. 2x times negative 5 is negative 10x, and negative 3 times negative 5 is positive 15. Now we're going to collect like terms again. So I'm going to deal with my squared terms. There's only one cubed term, so I can just write x cubed. But then I've got positive 2x squared subtract 5x squared, which is negative 3x squared. And then I've got negative 3x subtract 10x, which is negative 13x, and then plus 15 on the end because there's no other constant numbers to combine with it. Okay, so you can see from this that we've written it in the form x cubed, x squared, x, and then a constant on the end there. And you can see a is 1, b would be minus 3, c would be minus 13, and d would be 15. Question 13. An expression for the nth term of the sequence of triangular numbers is shown. Prove that the sum of any two consecutive triangular numbers is a square number. Okay, so any two consecutive triangular numbers. So consecutive triangular numbers are one after the other. And we're going to prove that the sum of any two is a square number. So if this is our first triangular number, so n plus 1 over 2 is our first triangular number. Our next triangular number can be written as n minus 1 times n over 2. Okay, so we're going to show that the sum of these gives us a square number. So we're going to add these together. Now, fortunately, we're adding two fractions that have the same denominator. So we're going to write it all over that common denominator. And then I'm going to expand the top. So we get n squared plus n. And then we've got plus n squared minus n. All over 2. Okay. So then we have n squared plus n squared. So that's 2n squared. N minus n. Cancel each other out. So we've got 2n squared over 2, which we can simplify to n squared. And by getting n squared, it must be a square number. Question 14. OAB is a triangle. So OAB is a triangle, and then OBC is a sector of a circle with centre O. Calculate the area of OBC. Give your answer correct to 3 significant figures. So if I want to find the area of a sector, it would be the angle inside divided by 360 times by the formula for the area of a circle. Remember, this formula for the area of a circle includes the radius, and both of these lengths here are radii. So I need to work out one of those lengths to then be able to find the area of this sector OBC. So now I'm going to use this triangle here. So I'm going to use the triangle OAB, or whichever way you want to call it. They called it OAB, so let's go with that. And I'm going to find this length BO. And I'm going to find this length using the cosine rule, because I've got 2 lengths and their enclosed angle. So I can use those to find this missing length. So the cosine rule would give me length OB squared is equal to 9 squared plus 6 squared minus 2 times 9 times 6 times cos of that angle 35. So OB squared is equal to 9 squared plus 6 squared subtract 2 times 9 times 6 times cos 35, which is 28.53157922. This is OB squared. We just want OB, so we're going to square root that, which gives us 5.341495972. So this is the radius of that sector. So now I'm going to substitute the radius of the sector into this formula. So the angle inside that sector is 80. So it's going to be 80 over 360 multiplied by pi multiplied by this, the radius squared. And because I haven't cleared my calculator, that's going to make it easier. So don't clear your calculator at this point, because then you're not going to have to enter all of this in. So we're going to put 80 over 360 times by pi times by the answer, because I didn't clear that answer for the radius, squared, and press equal. So that tells us that it's 19.91879993. So this is the area of the sector OBC. Double check what the question's asking for. Give your answer to 3 significant figures, okay? So 3 significant figures going on this line here. So 1, 2, 3. That 1 isn't going to change the 9, so it's 19.9 centimetres squared. (15a) Factorise a squared subtract b squared. So this is the difference of 2 squares. A is squared and b is squared, and the subtract gives us the difference. So the difference of 2 squareds means we need a positive and a negative version of this term here, so that the AB terms, if we were to expand those brackets, would cancel out to leave us with a difference of 2 squares. So we're going to write that there. Part B, show that 2 to the power of 40 subtract 1 is the product of 2 consecutive odd numbers. Again, even though it doesn't look like it, this is the difference of 2 squares. because 2 to the power of 40 is a square number, and and 1 is a square number. And by that I mean that 2 to the power of 40 could be written as 2 to the power of 20, because remember, when we're multiplying and the base numbers are the same, we add the powers. So 20 plus 20 would give us that 40, which is why it's a square. And then we'd have a -1 and a +1. Okay? Now what we can say is 2 to the power of 20 has got to be even, because it's a power of 2, and if we're multiplying by 2, we're going to get an even number. So 2 to the power of 20 subtract 1 must be odd, because the number before that even number would be odd. And then 2 to the power of 20 add 1 is also odd, because the next number on from that even number would be an odd number, because they alternate odd and even. Okay, so 2 to the power of 20 is even, so 2 to the power of 20 subtract 1 is odd, and 2 to the power of 20 add 1 is odd. Therefore, it's the product of 2 consecutive odd numbers, because this is the odd number before 2 to the power of 20, and this is the odd number after 2 to the power of 20. So, but you need to explain that. So I've said that's even, I've said they're odd. So 2 to the power of 40 subtract 1 is the product of this and this, which are consecutive odd numbers. Question 16. On the grid, enlarge triangle T by scale factor -2 with centre of enlargement -2, -2. So this is triangle T. We're enlarging it with a scale factor of -2, and the centre of enlargement is -2, -2. So that centre of enlargement is here. So we're going to plot the journey from this centre of enlargement to each point of this triangle, and then we're going to reverse that journey and multiply it by 2. The negative means we reverse it and do the opposite, and the 2 means we're going to do it twice as far, 2 times as big. So to get from here to the point of the triangle here, we've gone 4 to the left. So negative means instead of going left, we're going to go right. And then the 2 means instead of going 4, we're going to go 8. 2, 4, 6, 8. And there. And then we're going to do the same to this point. So we've gone 3 down, 3 to the left. So instead of going down and to the left, we're going to go up and to the right because of the negative. But we're going to do it 2 times as far. So instead of down 3, left 3, we're going to go up 6, right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, at this point, you could probably recognise that this point here is going to be 2 times that distance from the one we've just plotted. So it's going to be 4 times that distance, but you've got to make sure you're doing it in the right direction. So from here to here, it's gone to the left. So on this one, it would go to the right. Alternatively, plot that journey again. So we've gone 3 down, 5 left. Do the opposite. So we're going to go up and right, but we're going to go 6 up, 10 right, and then you're going to draw your triangle. So because we had a negative power, we are expecting that it's flipped in some way, and then that power of the 2 in that scale factor, not power, sorry, is what's made it 2 times bigger. Question 17. Here is a distance time graph. So we've got distance and time, and we've got a curve here, and that's important to be aware of. Part A, find an estimate of the gradient of the graph at time 2.5 seconds. You must show how you get your answer. So the fact that it's a curve is important here. When we've got a straight line and we find the gradient, then we do the change in y over the change in x, and that gives us our gradient. We don't have a straight line here, so we need to give ourselves one. So we're going to find time 2.5 here, go up to the curve at that point, and then we're going to draw a tangent to the curve. So what's important here with the tangent, guys, is it touches the curve but doesn't cross it. So we draw a tangent, a straight line at the curve at the point given, and now we're going to work out the gradient of that straight line. Okay, so let's pick 2 points. So that is (3.538), and then if we go with this point here, it's a 1.810. So now we can work out the gradient of this line. We're going to do the change in y divided by the change in x. So the y coordinate is 38 and 10. So we're going to do 38 subtract 10 over 3.5 subtract 1.8. Remember, it's an estimate, so there will be a range of values that you can take from this, okay? So that's 38 subtract 10 over 3.5 subtract 1.8, which is 16.4705. So I'm going to say 16.5 is the gradient. Okay, and I'm going to pop that on my answer line there. What does the gradient of the graph represent? Well, this is a distance time graph. What is the other variable that we use with distance and time? It's speed, isn't it? So this graph, the gradient of this graph is the change in y, the distance, divided by the time. So it must be speed. Question 18. A solid frustum is made by removing a small cone from a large cone as shown in the diagram. So this shape here is a frustum, and what they've done is we started with a large cone, then they've removed the smaller cone from the top to leave this shape here. The slant height of the small cone is 6 centimetres. The slant height of the large cone is 10 centimetres. The radius of the base of the large cone is 3 centimetres. Calculate the total surface area of the frustum. Give your answer correct to 3 significant figures. Now it gives us the formula for the curved surface area of a cone. Okay, so what we're going to do, we're going to find the surface area of this cone, the larger cone, the surface area of the smaller cone, subtract them from each other, and then this will tell us the surface area around the outside of this frustum, and then we need to add these 2 circles. So let's do that first. So the surface area of the large cone, so we need pi times the radius times the length, the slanted height there, okay? So for the large cone, it's going to be pi times 3 times 10, which is 30 pi. I'm going to leave it as 30 pi because it makes my life easier. When I find the surface area of the small cone, I need to know the radius. Okay, and it doesn't label that for me, and it's definitely not 3 because the base of the frustum is larger, okay? So what we need to recognise is actually the small cone and the large cone are similar shapes. And because we know the slanted height of each, we can work out a scale factor. And this will be the linear scale factor because we're dealing with height, okay? So 10 divided by 6... gives us a scale factor of, I'm going to leave it as a fraction, 5/3. So the radius of the small cone is 5/3. The radius of the small cone is the radius of the large cone divided by 5/3. So 3 divided by 5 over 3. 3 divided by the answer. So the radius of the small cone is 1.8. So now we're going to do pi times 1.8 times 6. So 1.8 times 6. So that's 10.8 pi. So if I subtract these 2 now, that's giving me the distance around the curved surface area of the frustum. So 30 pi subtract 10.8 pi. So this is the curved surface area of the frustum. So 30 subtract 10.8 is 19.2 pi. But for the total surface area of the frustum, I need the area of this circle and the area of this circle, then I need to add it to this. So actually the total surface area is 19.2 pi, add 9 pi, because it's pi r squared for the area of this circle. And then this, we said this was 1.8, so 1.8 squared is 3.24 pi. So we've got 3.24 plus 9 plus 19.2. So we have 31.44 pi. We want three significant figures. So let's figure out what 31.44 pi is. So it's 98.771. Three significant figures. 1, 2, 3. That 7 is going to round this 7 up. So it's 98.8. That's the total surface area. Question 19. Sana needs to draw the graph of y equals 3 to the power of x for the range of values from 0 to 4. And she's drawn the graph that's shown on the grid here. So this is Sana's graph. The question asks us to write down one thing Sana has done wrong. So the best way to approach this is to figure out if they've actually plotted the graph correctly to start off with. So if y equals 3 to the power of x, when x is 1, y would be 3 to the power of 1, which is 3. When x is 0, it would be 3 to the power of 0, which is 1. So this graph should go through 1, 3, and it should go through 0, 1. So 1, 3 looks about right, but 0, 1 hasn't gone through 0, 1. It's gone through 0, 0. So that's where I'm going to query this. I'm going to say it should go through 0, 1, and it clearly isn't because it's gone through 0, 0. Question 20. Prove algebraically that 0.123 recurring can be written as 61 over 495. So we're going to write this as an algebraic fraction. And what's really important to note here is that the recurring signs are only over the 2 and 3. So this value, 0.123 recurring, is technically 0.123, 23, 23, and it would keep going repeating the 2, 3. Okay, so I'm going to do two different versions of this now. Because I've got 3 digits here, I'm going to do 1000x. If I multiply this by 1000, I get 123.2323 recurring. And then I'm also going to do 10x, because that will give me 1.2323 recurring. And then now what you'll notice is the recurring values after my decimal point match exactly. So now I'm going to subtract these two versions from each other. So 1000x subtract 10x is equal to 123.23 subtract 1.232323. Well, when I subtract them, the decimal part's going to cancel out. So I'm doing 123 subtract 1. So 1000x subtract 10x is 990x, and 123 subtract 1 is 122. So x is equal to 122 divided by 990. Now I need to show algebraically that it can be written as this. Well, if I half 122, I get 61. So if I half 990, I get 495. So I've shown that that recurring decimal can be written as that fraction. Question 21. So we're going to solve this equation that has algebraic fractions. Okay, so what I want to happen is I want to eliminate these fractions on this side. So to eliminate these fractions, I need to multiply by x plus 4 and I need to multiply by 2 minus 2x. Now this is where you need to be careful. When I multiply by x plus 4, that's going to multiply the numerator of this fraction and the right hand side of the equation. Okay, so that would leave me with 1 plus 3x plus 4 over 2 minus 2x equals 1 times x plus 4. And then when I multiply by 2 subtract 2x, I've got to multiply this term. It will cancel out the denominator here. And then I need to multiply on the right hand side. So multiplying by 2 subtract 2x gives me 1, 2 subtract 2x plus 3x plus 4 plus 1 times x plus 4 times 2 minus 2x. So now it's a case of expanding and simplifying. So this 1 times just leaves us with that. 3 times x is 3x, 3 times 4 is 12. 1 times leaves us with that, so x times 2 is 2x. X times negative 2x is negative 2x squared. 4 times 2 is positive 8. And 4 times negative 2x is negative 8x. Now I'm going to gather everything to the left-hand side. And the reason why I'm gathering everything to the left-hand side is because I don't want a negative x squared term. Okay, so let's just simplify a little first. So we've got 2 plus 12 is 14. Negative 2x add 3x is x. So the left-hand side simplifies to x, add 14. The right-hand side simplifies to negative 2x squared. 2x subtract 8x is negative 6x plus 8. So I'm going to add 2x squared to this side. I'm going to add 6x to both sides. And then I'm going to subtract 8 from both sides because I need a quadratic to be equal to 0 to be able to solve it. So now I'm going to attempt to factorise. So that would be 2x and x. Two numbers that multiply to give me 6. 1 and 6, 2 and 3. Add to give me 7, but one of them is going to get multiplied by 2. So it's going to be this pair that I use. So it'll be plus 2 and plus 3 is equal to 0. So for this bracket equal to 0, 2x is equal to negative 3, so x is equal to negative 3 over 2. If the right-hand bracket is equal to 0, x is equal to negative 2. So we've got two solutions here. X equals negative 3 over 2 and x equals negative 2. Question 22. Given that the vector A plus the vector B is parallel to this vector, find an expression for B in terms of A. Okay, so if the sum of these two vectors is parallel to this vector, then they must be equal to a multiple of that vector. Okay, for them to be parallel, they've got to be a multiple of each other. Okay, so from this, I can read that actually 2a plus 8b must be equal to 13k, and 6a plus 2b is equal to 6k. In fact, we don't need the k's there. So I've got two simultaneous equations here, guys, that I can work with to solve. So let's make our b's the same. So let's times this one by 4. So I've got 2a plus 8b equals 13. And 24a plus 8b is equal to 24. Now I'm going to subtract these equations to eliminate the 8b because they're both positive. Okay, so 24a subtract 2a is 22a. 24 subtract 13 is 11. These have cancelled out, so a must be equal to 11 over 22, which is 0.5. I'm going to substitute that in to find b. So if a is 0.5, So 2 times 0.5 is 1. So 8b is equal to 12. So b is equal to 12 over 8 or 3 over 2. So a is 0.5, b is 3 over 2. Okay. So if b is 3 over 2, this is 1.5. 1.5 is 3 times 0.5. So an expression for b in terms of a is b is equal to 3 times a. So b is equal to 3 times a. Question 23. A circle has equation x squared add y squared equals 25. The point P with coordinates -3, 4 lies on the circle. Alex says that the tangent to the circle at P crosses the x-axis at the point -8, 0. Is Alex correct? You must show how you get your answer. Okay, so we're dealing with a tangent to a circle. We've got point P, which is the -3, 4 coordinate, and we've got this circle here. Now this circle must have a centre of 0, 0 because of how it's written with the x squared add y squared. And the radius is the square root of 25, which is 5. Okay, so the first thing we're going to do is find the gradient of the line or the gradient of the radius. So if we imagine we've got this circle, this is our centre 0, 0. Point P is -3, 4, which would be, say here, if that's -3 and that's 4. So we're finding the gradient of this line here. Okay, so we're going from 4 to 0. That's a change in y. And then from -3 to 0 is a change in x. Okay, so we have a -4/3 gradient. Okay, because we have a -4/3 gradient, if we're finding the equation of the tangent at the circle, which we're going to have to find to see if this point is where it crosses the x-axis, okay, we need the perpendicular gradient. So the gradient of the tangent is the negative reciprocal, so it would be 3/4. So y equals 3/4x plus c would be the equation of the tangent. We know that the tangent is at the point P. So when x equals -3 and y equals 4, 4 equals 3/4 times -3 plus c. So 4 equals -9/4 plus c. So c equals 4 plus 9/4. Do that in your calculator, guys. 4 plus 9/4 is 6.25. So the equation of the tangent is y equals 3/4 x plus 6.25. Now, what we need to do is decide whether or not the tangent to the circle at this point crosses the x-axis at -8, 0. So when y is 0, what does x equal? So when y equals 0, so 0 equals 3/4 x plus 6.25. So 3/4 x equals -6.25. So x equals -6.25 divided by 3/4. So x equals -6.25 divided by 3/4. What did I do? Put an extra negative on. Equals -8.3 recurring. So Alex is not correct. Because it crosses at -8.3 recurring, not -8. And we've shown all of that there with our working. Question 24. There's a total of y counters in a box. There are x pink counters and 5 blue counters in the box. The rest of the counters are green. So we've got pink, blue and green counters. The ratio of x to y, so the number of pink counters to the total counters, is 1 to 3. Frida takes at random 2 counters from the box. Find in terms of x an expression for the probability that Frida takes 2 counters of the same colour. Give your answer as a fraction in this form where a, b, c, d and e are integers. So integers means we want whole numbers where those letters are. So first things first, here if we look, it's all in terms of x. But we know that the total number of counters in the box is y. So I'm going to need to at some point express y in terms of x. And I can do that from here. Because if y is 3 and x is 1, then y is 3 lots of x. And we're going to use that later. We're going to park it here, but we're going to use that later. Now we need to look at these probabilities. So we want the probability that Frida takes 2 counters of the same colour. So we're looking for the probability that she takes pink and pink, probability that she takes blue, and the probability that she takes green and green. Okay, so probability of pink then. So the first time she picks a pink counter, we've got x possible outcomes out of y in total. The second time she picks pink, we've got 1 less pink and 1 less in total. So our probability of picking pink and then pink is x squared minus x over y squared minus y. I've multiplied the numerators and the denominators. Let's do the same with blue. So there are 5 blue counters. So the first time Frida picks a blue, it would be 5 out of y. Remember, y is the total number of counters. The second time Frida picks blue, there's 1 less blue to pick from, so that's 4, and then there's 1 less counter in total, so that's y subtract 1 again as the denominator. So 5 times 4 is 20 over the same denominator, and we'd expect this with probability. Okay, probability of green and then green. So the probability of picking the first green will be the total number of counters, take away how many pink and how many green. So subtract x and subtract 5 out of the total. Then there would be 1 less green to pick from. So it would be the total subtract x subtract 6. That's 1 less over y minus 1. So when we simplify this one, it's a little bit trickier. So I'm going to put these guys in terms of x fully. So if I add these two probabilities, I've got x squared minus x plus 20 over this y squared minus y. But I'm going to do it as this, look. 3x squared minus 3x. Remember, there was a reason why we needed it writing in terms of x. Plus this thing here. Okay, so y times y. That's where it gets a little bit complicated. So y times y is going to give us y squared. Y times minus x. In fact, let me make this even easier. Y is 3x. Remember that. So we're going to substitute with that with 3x. Substitute that with 3x. So 3x subtract x is 2x minus 5. So you've got 2x minus 5 and then you've got 2x minus 6. All going to be over this same denominator here. Okay? So now let's simplify this a little bit further. So we have x squared subtract x plus 20 over 9x squared subtract 3x plus 2x times 2x is 4x squared. 2x times minus 6 is minus 12x. Minus 5 times 2x is minus 10x. And minus 5 times minus 6 is 30. And it's all over that same denominator. So I'm not going to write it again. I'm just going to simplify it even further. So x squared plus 4x, 5x squared. Negative x, take away 12x is negative 13x. Take away 10x is negative 23x. 20 plus 30 is 50, all over 9x squared minus 3x. Okay, so we have x squared x and a constant, x squared x and a constant, and then we have an x squared and an x squared and an x. So let's just make that nice and clear. on our answer line. There we go.